All right, so yesterday we talked about salts and predicting whether a salt would be acidic or basic or neutral. We know that if a salt comes from a strong acid or strong base, it will be neutral. We know that a salt from a strong acid and a weak base will be less than 7, will be acidic. We know that a opposite way around, a strong base and a weak acid will be basic. We know that if it's come from 2 weeks, we need to compare the Ka and Kb values. Okay.
What slide number is this?
This is slide number 36.
Like you when I hit you with that promptly grade my essay.
So today we're going to calculate the pH of a salt. Okay, we're going to talk about pH of a salt today, and tomorrow we'll talk about pH of a buffer. We're going to have a quiz on Friday. Okay, and we're tracking for a test on Tuesday. That test got pushed back a little bit. Okay, that test got pushed back a little bit. So today we're going to talk about the pH of a salt. So define the pH of a salt. So here's our question. Calculate the pH of a 0.45 molar solution of NH4NO3. I cannot just take negative log, can I?
Can we write the question?
Yes, but I can talk about this while you write the question. I can't just take negative log, okay? I cannot just take the negative log because to find the pH is the negative log of H plus. There's no H plus there anywhere, is there? So I can't take negative log of 0.45. And I can't necessarily starting out use an icebox yet, okay? I'm going to need an icebox, but it's going to take a moment to get to my icebox, okay?
You're going to have to repeat all that because that's not listening on my
You go back and listen to my video again.
My slides are loading.
So I can't just take it, okay? The salt is, now, first off, the salt is acidic, okay? The salt is acidic because it comes from NH4OH, ammonium hydroxide, the weak base, and NO3 comes from nitric acid, which is a strong acid. So we calculate the pH like we would calculate the pH of a weak acid. Okay, so that means.
Did you say that NH4 came from a
weak base?
Weak base.
Weak base. Ammonium hydroxide is a weak base, which is kind of weird in some ways. That ammonium hydroxide is weak base. They didn't really talk about this, but if you go back to your solubility rules, we said that all strong bases and ammonium hydroxide are soluble. Okay. But it's kind of like hydrofluoric acid. It doesn't dissociate 100%, it dissociates a lot, but we wouldn't necessarily call it a strong base. It is probably the strongest of the weak bases. Okay, it's probably the strongest of the weak bases. So I need to be able to write an equation. Okay, I need to be able to write an equation of how the salt would hydrolyze. And I do that if I add NH4 plus ammonium to water. Now, if I was doing this as a base, I would, I'd kind of do it the other way, okay? I would write a Kb value, okay? I'd write a Kb value. Still dissolve it in water. So I know that NH4 plus water, I know that in this case, my NH4 plus is acting as all 3 of my acids, is acting as a proton donor. So it would be a Bronsted-Lowry. Is acting as an Arrhenius in that it's producing an H plus in water.
So is water never included in?
No, because it's a liquid. Okay.
Oh yeah.
Because it is a liquid, and it is acting as a Lewis acid because it is accepting the pair of electrons. Okay.
Is this why we just do aqueous solution?
Yes, ma'am. No, still just doing aqueous solutions. So as Henry just pointed out, I don't need to put water in my Ka value, and I won't have water in my icebox either. Okay. So it's just products over reactants. Now, a problem with this is that I don't have a Ka value for this. There's no K. If I go look at my list of Ka values that I just published, that's not any ammonia is nowhere on that Ka list, is it? Just take my word and it's not. But we know that ammonia is a base, and we see it on the Kb side. So if I know Kb, can I find Ka?
Yeah, that's right. Ka is, or Kw is Ka times Kb.
Very good. As Balin pointed out.
And Kw is equal to 1 times 10 to the negative 4.
Yes, I can calculate Ka, which is what I need for my icebox, by I can calculate by K B, I mean my Ka, because I know Kw, which is 1.0 times 10 to the negative fourth, and I know my Kb is 1.8 times 10 to the negative fifth. So if I divide those two out, I get Ka to equal 5.6 times 10 to the negative 10th. Give me a second to come back up. I'm ready to do my icebox now, okay? So this is the step you're going to have to do when you're talking about the pH of a salt. You're going to have to divide Kw by either Ka or Kv, depending on what you're looking for. Like I said, if this would have came from a weak base, if this would have been basic, you would have had Ka and solve for Kb. Okay. So there's my Ka expression. I've already written that, and I'm ready to fill out my icebox. What do I? So I can start filling out my icebox. What do I know in this icebox problem?
There was 0.45 of the solution, but that's not.
So which one of those is that?
NH4.
What, Hannah?
NH4.
NH4.
Why though?
Because ammonium nitrate is soluble. That is our go back to our solubility rules. All nitrates are soluble, all ammoniums are soluble. So I have 0.45. Now, once again, if that could have been something different, that would have been a mole ratio. If that would have been ammonium sulfate instead of ammonium nitrate, this would have been 0.90, okay, because I would have had to use my stoichiometry. What about my other things? Well, how much of that do I have? 0 and 0. So I'm going to minus x for the NH4, won't I? Plus x, plus
This
x.
is a question I had on my homework. How come when we wrote when we wrote the E, why is it not 0.5 minus x? Why is it just
Okay, it could be.
okay?
It could be. But what you're going to find out when Kb or Ka is 1,000 times smaller than the concentration, it's not significant.
Okay.
So you could have written, we're going to do the same thing here. You could have written 0.45 minus x. But then you would have to use your quadratic, thank you. Then you would have to use your quadratic formula, okay? We would have got the same answer, and what you would have found out is that significantly there was no difference.
Okay.
So this is just an assumption that we make to make our lives easier, okay? So x and x here. So now I'm ready to plug that into my Ka expression. What? Ka is what we found. We found Ka by doing Kw divided by Kb. And so it's 5.6 times 10 to the negative 10th. That was the last thing. I might have skipped through that in the last slide. And multiply each side by 0.45. Take the square root of it, and x equals 1.6 times 10 to the negative fifth.
Instead of multiply both sides
by 0.45, and then take the square root of it. I didn't show that actually work that step explicitly, but I did it. So I found my answer, right? No, I found x. So now what do I need to do? Plug that thing in the thingamajig. I'm gonna need a few more details than that.
Plug X into the icebox problem.
Sarah's correct. Take the negative log of this. Because I want pH. So I'm gonna take the negative log of it. pH is the negative log of this number
So what's the whole point of the icebox?
to find out what x is. I mean, I could work this problem. I could work this problem out without an icebox because I know that it's going to be x squared over the concentration on the top.
So we don't have to.
Lamaya has it. No, you don't necessarily have to. You don't have to write out the icebox because we know that this is a little bit easier thing to do. We're getting so much familiar with it, and we know that when we've been doing these iceboxes of these weak acid and weak bases, we know this is what they always simplify down into. K equals x squared over the concentration. So I don't necessarily need the icebox explicitly.
Will the number, will that always be on bottom?
This number?
The 0.45.
Yes. The initial concentration, yes.
Like, and for our sake.
For your sakes, for the purposes of acid and base concentrations, yes, ma'am.
So we don't have to do any of this and do the X's or anything. Because it's always.
Well, I don't care about the 0.45. I don't care about that.
That's what I was, no. For that, equation, that one right there. We don't have to do any of this because it's always going to go to
Yes.
there is what I'm at.
Yeah, yes. This 5.6 times negative 10 equals x times x over 0.45. The only thing that ever changing is the k and the initial concentration.
So, but it's, that number's always going to be on bottom.
Yes.
Oh, then there's no sense with that.
So now I need to take the negative log of that, and I found the negative log is 4.8. So that is relatively acidic. Any questions about that? All right. So what's new today, the only thing that's new today is we weren't given the K that we needed. So to find the K that we needed Ka and we only had a Kb. So what was new is we had to do 1.0 times 10 to the negative 14th divided by the Kb. That's all I got for you today.